Yo, deep fake with another one, fam. So I just want to show y'all what these homemade microwave guns look like and how they're manufacturing them and putting them on the streets. This isn't a military microwave gun. These are homemade guns. They're getting the technology, the skills, and they can make these and break these down in like a couple minutes. You know what I'm saying? So it's hard to catch them with them. And if you do catch them, they'll just say it's a piece of scrap microwave.
Alright, enough ranting. Let me show you how this works. Now, essentially what this is a 2,000 watt microwave oven, only it's directed forward. Now, you can't get 2,000 watts just from any power outlet in your house, so what I had to do is use two separate power outlets, each on a different fuse. Unless I felt like bypassing the fuses altogether, but don't do that, that'd be dangerous. I made it symmetrical across a 2x4 piece of wood. On each side there's a high voltage transformer. By high voltage I mean in excess of 2,000 volts. A high voltage capacitor and of course a microwave magnetron. This is where the radiation is actually emitted inside of the microwave oven. And I should also not forget to mention that everything is grounded together using a ground plane just like this on each side. This entire circuit that a microwave oven uses to operate is a voltage doubler. So what it will do is it will take the input, 60 Hz AC, 120 volts, or 240 depending on where you live, and it'll use a transformer to step it up to about 2,000 give or take. And then the voltage doubler circuit, which consists of a capacitor and a diode, which is that diode down there, very high voltage diode, not a lot of current though. That will be used to create a voltage peak of about 4,000 volts. And this is minimum for a magnetron to create electromagnetic radiation around 2.4 gigahertz, usually into a microwave oven cavity, but here it's into a horn that both directs it forward and amplifies it. Also inside the horn I put aluminum tape, that's down here actually. Here we go. Aluminum tape on the inside to prevent any waves from getting stuck in crevices, or more importantly to make all of these edges flush with the waveguides and the horn. To make a horn, I found it best to trace trapezoidal cutouts onto a sheet of metal and then fold it up into a rectangular horn. The dimensions for a waveguide can't just be anything that we want. They need to be pretty specific to get waves to propagate through it. There's actually a lot of mathematics that goes into designing a waveguide. Here's a good rule of thumb to keep in mind though. The frequency of the wave that you're using is proportional to the speed of light divided by 2 times the height of the waveguide. And if this equation looks familiar, it should. We know that the frequency of any wave is equal to the speed of light divided by lambda, its wavelength. So essentially all this means right here is that the waveguide's height needs to be half of the wavelength. Using this equation we can solve for what the wavelength of microwave radiation is. We know that microwave radiation is around 2.4 gigahertz, so if we take the speed of light and do the algebra, we find it to be about 12 centimeters in wavelength. Which is kind of big for a wave, but that's expected since it's low frequency. If that's the case, that means that we're going to want the height of our waveguide to be half of that, around 6 centimeters. Let's see how a microwave oven compares. Alright, let's go ahead and start taking this apart. I want to get at these waveguides from the microwave back here. I need to take off the horn first.
Now this is how they can break it down and stash it. Even though he's actually looking for a component, he's not assembling it to hide it.
I suppose this could make a nice, I don't know, lampshade or something. Now that we have this waveguide off of our microwave gun, let's do a calculation and see what this distance is right here. This is supposed to be covered up, so that's irrelevant to the actual function of the waveguide. I have here a caliper, which is zeroed,
Let me pause it for a minute. But you see how easy you can just break these down. These are basically house parts. These are light switches and microwaves and extension cords. You know what I mean? But it's based off military weapons.
Extremely dangerous. If it's broken, you get particulates in your mouth or your lungs, you could develop a condition called borreliosis, which is incurable and will eventually kill you. So just avoid them. In my last video, when I was talking about how magnetrons operate, I mentioned that a magnetron's antenna emits waves in a pattern that looks something like this. These lobes are where you can expect the microwave radiation.
Sorry if this is boring you, but I just want you to understand the way these microwave guns work. Let's see if I can get it to the...
It'll lose control of its systems and plummet back to Earth, but it's not as effective as I was hoping for. I was kind of hoping that the interference from the microwave gun would prevent the signal from the controller from communicating with it, but that wasn't the case. But still, it was pretty cool to knock a drone out of the sky with a microwave gun. Also, it may have been illegal. So let's just keep this between us, okay? As always, I'd like to remind you to stay safe and have fun. And of course, as always, thanks for watching.
Deep fake with another one. So it can not only be used as a microwave EMF gun, it can be used as a EMP gun to fry circuits on computers, and once you remove it, the circuits and the electrical devices will go back to the original state. So they can play head tricks with it. Deep fake with another one. You.